Hey guys, today we'll try to understand bitwise operators. Now, when I'm talking about bitwise operators, these are normally used to perform bitwise operations on integer type object. Okay, so bitwise operators, these are used to perform bitwise operations on integer. Let's be very specific. Integer type objects. Yes. Now, however, it is used on integer type object, instead of treating the object as a whole, it is treated as a string of bits. Yeah. We'll see this. Yeah. Different operations are done on each bit in the string. So each bit is been operated separately. We'll see that as well in the examples. Now, Python has 6 types of bitwise operators. So the different types of operators in this are different types of operators. So the first one is, let me see the indentation I have kept for earlier ones. I'll keep the same thing so that, okay. So the first one is, uh, the first one in the lot of 6 different types of bitwise operators is AND. Yeah? And it is denoted by ampersand. Yes. Next is OR, which is denoted by a pipe symbol. Next, further to it is XOR, XOR, which is denoted by an exponential symbol. Next is NOT, which is denoted by a approx symbol. And one is left shift, which is denoted by an double arrow symbol. Yes. And the other one is right shift, which is denoted by a double arrow again, but to pointing towards the right. Yes. Let me use some other sign instead of arrow so that we can differentiate it. Yes. So these are different types of bitwise operator. Let's try to understand it one by one. We'll first try to understand the AND operator. Yeah. So when we are talking about AND operator, uh, so bitwise AND operator. When we are talking about this, which is ampersand symbol, now bitwise AND operator is somewhat similar to logical. If you remember my logical video in my previous sessions, uh, similar to logical AND operator. It returns true only if both the bit operands are 1. Yeah, that is true. All the combinations are like, if you say for AND, let me put this in text so that we can write all the possibilities. So if I have once AND operator, if I have 0 and we have 0, the result would be a 0, because 0 is considered as false. If both the values are false, the result would be a false. Suppose one of the value is true and other is false. Still, the AND operator will give a false value. Suppose either of the values, so it will give me a false. Suppose my both the values are true, which is 1 and 1. You know true is denoted by 1. Then only the value would be returned as 1. For an example, let's see an example how it operates. So suppose A is equals to 60. I have this variable which has A as 60 and B is equal to 13. Yeah. And if I try to get a logical AND operator for this, so I say print A, yes, A, which is A, which is 30, and we have B, which is 15. Yes, so I mention it as 15. No, you don't need to put it in code. And for the logical operator A and B, what will be the value? Yes. So let's see what is the value that comes up when I have this A and B. Yes, we have this logical operator A and B, which is an AND operator. Let's see what is the value that it returns. Now, what actually happens is it converts A into a binary value, B into a binary value, and then operates the ampersand, which is AND condition. Now, to understand it, let me print the binary of A. Yes. So A, which is our value above. Yes. Let me put the binary value. You know how to convert it to binary. We have seen this earlier when we have casted it. Let's print both B as well. Yes. Let's see what are the binary values of this. So A and B has this binary value. Now what happens is when we are trying to run this values, what it does is it, let me put it in text. So A has a value of 0, 0, 1, 1. We have double zero, sorry. Let me complete it. Double 1, 0, 0. Yes. So this is the value you can see here. 0, double 1, double 1, double 0. Yes. B is considered to be 0, which is binary. If there are lesser value, then it will take it one more 0. So this four integers will be treated at the last four integers and others would be replaced by 0 here. And what happens is let me put the B value as well, which is 0, 0, 0, 1, 1, 0, 1. Yes. So this is 1, 1, 0, 1 here, which you can see here. Yes. And 0B is treated as 4 zeros, which is the binary separation for this particular value. So since we have converted, now we try to put the AND operator. Yes. Now what AND operator does is, so if I try to do an AND here, it returns me a value based on the above binary numbers that we have got. So 0. So we said bit by bit. When I initially told about the definition, it says What does bitwise operator does is it slow down. Mouse is getting stuck. Give me 1 minute. Okay. So where were we? Okay. So what we said is, so different operations are done on each bit in the string. Okay. Now this is a string. What it is? This entire thing is a string. Now each bit means every bit, 0, 0, 1, 1, double 1, 0, 0. Okay. So each bit is been calculated or compared. So 0 against 0, which is false against false, would be a 0. Yeah. False against false would be a 0. Yeah. False and false. Yeah. True and false would be a false. Yes, we have seen this in this. What will be the value in an AND operator? That is what we are trying to match here. Again, true and false value would be a false. True and true value would be a true. Yes. True and true value would be again a true. False and false would be a false. False and true value would be a false. So this is the binary equivalent of the answer that we got. That was 12, A and B. Let's see whether it is true by putting it in the code. Uh, one second. It's not going. Somehow it is taking it as a, let me put it here as a comment. See, it takes as a comment. Yeah. So you can see this. I should have put it above, but it is somehow not taking it. Uh, Let me again put it in text format. It's too much. Um, okay. I guess this would be okay. Yes. So this is how it looks like. So this is an example. Put it as yes. So this is how it operates when I say A and B. Okay. So let me see this answer that I have got, whether it is right or wrong, whether it gives me the value as 12. How would I check it? By doing the casting. Yes. So how do I need to convert it to an integer. So I'll say integer. I'll say print int of, yes. So this was my string that was supposed to be converted. Since it is string, I need to put it in double quotes. Yes. Comma. I want to convert it to a binary. So binary integer. So I'll say 2 and I'll say enter. So let's see whether my answer is right. Yes, 12, which we have got above. When I try to evaluate A and B. Yes. So this is how it is evaluated at the backend when I'm talking about bitwise operators. So let me highlight this. Bold. That would be a separate. Yes, bitwise operator. Let me see how I have highlighted my earlier sections. So I have a consistent marking on this sections. Just give me 1 minute of my sections. Okay, this sounds good. So this was bitwise and operator. Okay. Now similarly, bitwise or operator. Let me take this similar thing so that we are quick in explanations. So bitwise or operator. So if I say or, which was a pipe symbol, yes. Now it happens. So if I say 0 or 0, it will always return a false value, which is a false or a false value. It will return a false value. True or a false value, or false or a true value, both will return a true output. Again, if I have a true or a true value, it will always. So in all these cases, it will return a true value. Only one case where both the values are false, it will return me a false value. Yeah. Let's use the same example that we had earlier, but with a or operator. Yes. So which was the example? Okay, 60 and 13. So let's use this example in the code and we'll use the OR operator and we'll run this code. Let's see what happens and what is the answer. So it gives me a value as 61. Now let's try to find out whether the value that we are getting is right or wrong by first converting into a binary number, which is this one. Yes. And since this is the binary and we have to evaluate now as we did earlier. So we take this. That was the example. Okay. So this is the example that we have. We have the OR operator here. Yeah. So as we said, false and false will return you a false value. False and false will return you a false value, which is right in the case which we have got as of now. False and false again, it will be a, okay, let me check the binaries, whether I have put it correctly. Yes, I have put it correctly. So I need to correct it back. So false, false would be false. True or false would be a true. So this will change. True or false again will be a true value. True and true both would be a true. True and true again would be a true value. Yes. Now false, this false and this false would be a false value. So this is 0 is right. So again, this false and this true would be a true value. So we need to change the last value. So this is the binary format that we have got for our value. So let's see whether we are able to convert it to integer and see our answer of 61 is right. How do we do that? Is by, again, print. I'll say casting that we have to do. So I'll say int of this number that we need to cast to an integer, which is a binary number right now. So the answer should be 61. Yes, this is what the answer that we received when we try to evaluate A to B in an earlier expression. Yeah, so this is how beat by beat it is evaluating the value of both the operands and gives you an answer in binary form, which again converted to an integer will give you the answer. Yes. Now let's see how XOR works. Now, the term XOR stands for an exclusive OR. It means that the result of OR operation on two bits will be 1 if only one of the bits is 1. So how it happens is, let me take the same again, let me copy this. We'll use it as a new thing for XOR. Yeah. As XOR, its operator symbol is it is an exponential sign. Let me make it exponential here. Yes. Let me change all the signs first, then we will try to explain. Yes. So what happens is in XOR, it has to be exclusively OR. So either of the one condition has to be true. Both cannot be true or both cannot be false. So it will return for both false, it will return a 0, which is right here. Either of the condition has to be true. So one, this is true and this is false. So it will return a true value. Again, here, this is a false and true. So it will return a true value. But if both the values are true, it will return a false value. This is where the difference between OR and XOR is. Yeah. So let's try to reproduce the same example that we had for OR as well. So what example was A equals to B. Yes. And we'll put the XOR symbol. Let's see what is the answer. So it gives me an answer as 49. Now let's check if the answer that we have got is right by converting it to bin again. Yes, here it is. So using the same symbols again as example. Yes, in XOR both has to be exclusively uh, true. So this 2, where we have both the values as true in this position, this will turn to be 0. Yes. So both will return as 0, whereas where we have exclusive OR condition where one is 0 and one is 1, where that is one is false and one is true, it will return 1. Here you can see this. Yes, that is so. Yes. So let's check this value whether we have the value that we have got is right. Yeah. So what we need to do again is run this command to convert it to integer. We'll take this value, the final value that we got from XOR, and we'll run it. And we check it has to return a value as 49. Yes. Perfect. Which we have got here earlier. Yes. Simple. Now let's look into the next operator, which is not operator. Yeah. So what not operator does is, no, let me put it properly. So not is symbol. Okay. So what does not operator does? Now not operator does is, this operator is the binary evaluation of logical not operator. It flips each bit so that 1 is replaced by 0 and 0 by 1 and returns the complement of the original number. Yeah. So how it works? Let me put it in an example. So either way, okay, for an example, one is complementary. So 1 minus 1, that is 0. Yes. So 10 is complement 10 minus 1, which is complement is 9, which is the complement, the binary is 001 001. Yeah. So to understand this, uh, Python uses two's complement method. For positive integer, it is obtained simply by reversing the bits. Yes. For negative numbers, minus x, it is returned using the bit pattern for x minus 1 with all its bits complemented, switch from 1 to 0 or 0 to 1. Hence, for 8-bit representation, minus 1 is complement of 1 minus 1, that is complement 0, 1 minus 1 is 0. 10 minus 1 would be 9, which would be if I put it in a bitwise manner, it would be 4 times 0, 1, 0, 0, 1. And then it will negate it. So it will convert the zeros to 1 and ones to 0. So 9 would become 1, 1, 1, 1, which was initially 0, 0, 0, 0. Yeah. So let me put it this way. So if I put it as an example, yeah. So yeah, you can see minus 1 is complement as 1 minus 1, which is bit, yeah, which comes to the value as 0. 0 has a value as 1, 1, 1. So if I have 0, 0, 0, then the value would return as 1. Yes. But if I have minus 10, it will complement it at 10 minus 1. Yes. And the value would be 9. 10 minus 1 is 9. Yes. Now to complement it, the 9, if I write it in bitwise manner, it would binary manner, it would be 4 times 0, 1, 0, 0, 1. And if I put it in not format, then it will reverse this 4 times 0 to 1, which is you can see here, and then 0, 1, 1, 0. Yeah. Let me use some examples. So suppose I have a equals to 60. Yeah. And I want to print A, which is A, yeah, and I want to print not of A, yeah, which is not A. I'll say A. Perfect. Let's see what is the output. Should give me, okay, let me see what is the error that I've got. Okay, I have not added a comma. So you got a 61, minus 61. Yes. So this is how it gets added. So how it got to minus 61? You have seen that? Yes. So it added 60 minus 1. Yeah. Which was added since it was minus 10, it got to plus 10. So 60 would become minus 60. Minus 60 minus 1 would be minus 61. This is the basic mathematics that we have for a bitwise not operator. Yeah, pretty simple. It's pretty straightforward, not need much of an explanation. Let's move on to a next operator, which is bitwise right shift operator. So right shift, which is presented by, let's try with left shift first. Okay, let's go step by step as we have told in a initial different types. Yeah. So left shift operator shifts most significant bits to right by the number on the right side of the symbol. Yeah. Hence, if I put X left shift 2, it causes 2 bits of the binary representation of to the right. So what happens is, so let's see, I'll give you an example for this. So what could be a good example? Let me copy this. So suppose I have A equals to 60. Yeah. And I say uh, shift by 2, shift to left by 2. So if I say A, shift to left by 2, Yes, so it shifts the digits and gives me the value. So the value I get is 240. Now, what happens in the bits exactly? So let me first show you the binary of A. So in binary of A, you have the bit as 0, 1. So exactly the bit is 0, 0, 1, 1, 1, 0, 0. Yes, so these are 4 digits here and these are 4 digits here. So what happens? It shifts this entire it shifts this entire thing by 2 digits. So this 2 digits will move and it will move to the last. Yes. So the ending digits get moved. So let's see the value of this particular thing by getting an integer of it. So we have shifted. So you can see the binary value of A, which was 60, is this way. So this is how the binary way of representing a int value of 60. But when I say shift left 2, it shifts its bits by 2 and adds 0, 0 at the end. So it becomes this value. So let's see by converting this value to int. So what happens is comma 2, yes, this should give me a value of 240. Yes, sounds great. Same way for right shift operator. Now right shift operator, this time we shifted the values to left. Now we'll shift the values to right. Yes, so the arrow will point towards right. Okay, let's use the same example of 60. So we have the binary values. What are we getting is 240. Okay, I need to change the binary to right, which I haven't done. So let me run this again. It gives me the value as 15. Yes, let me check whether what was the binary of it. The binary of 60 is this, which you have seen earlier. Yes. So this binary, what it was? 0, 0, 1, 1, 1, 1, 0, 0. Yes. So this were our 0, double 0, double 1, double 1, double 0. So when I am shifting anything to the right, it pushes the values to the right. So what happens is it cuts down this value, moves this double 1 to the right, and adds 2 0 at the start. So the value becomes this way. So there are 4 zeros and 4 ones at the last. So let's see what is the int value of this right shift. Yes. 2. Yes. And here is the value. Let's say it is 15. Yes, that matches the. So I hope you understood how bitwise operators work. It works bit by bit on each of the operands strings so that you get a final output based on the various and or operators that you work on with. I hope you understood the concept and you will use it. Thank you so much.